everyone, and welcome to Let's Stump Jen, the show where you all get to try and stump me and I get to enjoy it. How is everyone today? I see that we've got Ricardo and Sammy Jenkins in there, and Ian Davenport, Paul Kamish, Never Again, Jeff, the Godless Scummer, and Ed, Grumpy Old Dude. Hi guys, you're all fucking awesome, love yous. So if you guys have some questions, physics, maths, science, whatever, anything, you can try and stump me. You probably will stump me because I am good at some things and other things I know fuck all about. But that's always good because I get to learn. Hi, Peter. It's one of those things. Try and stump me because I just love to be stumped. You have a tree ready to stump me with, do you, nerdy? Is it a nice big one? Because I like big trees. Hi, Hopswatch. I enjoy being stumped, Sammy, because anytime people throw things at me that I don't know about, I then learn about them, because it's improving my general knowledge, and improving my general knowledge is improving myself, and that's what we should all aim for, is like improving ourselves, you know. I don't want to be ignorant, and one of those things is learning what I'm ignorant about, and people stumping me with information that is factual, and that helps me learn, helps me be a better person. So yeah, I'm really happy when you stump me. I'm quite happy too when I can give an answer, but I'm really happy when you guys stump me, because it's a good thing. It's a good feeling being stumped. Yeah, no, I'm not subtle at all. Exactly, Sammy. We all need a good stumping. Hi, Amber. How are you? So, yeah, well, why don't I get us going with a few sciencey things whilst people try to think things that they might like to throw my way and see if I can figure them out. Yeah, I've got a light that's doing weird things to my face. That's cool. Alright, so NASA's OSIRIS-REx probe, the one that got sent to asteroid Bennu, to retrieve a sample and come back, which is a phenomenal piece of engineering. Previous to that, all we've been able to do is crash land on asteroids, which is pretty sad because we don't get good data from that. So to be able to land down, smack the rock, pick up a sample and fly back to Earth is fucking brilliant as far as I'm concerned, and just shows our own ingenuity as a species. However, there's a slight problem, because on the trip back now, it appears that the spacecraft itself is leaking samples. So the dust samples and soil samples it's picked up are leaking back out into space. And without figuring out a way to properly hold them there for the rest of the trip, this could end up being an entirely wasted, aside from what we've learnt about landing on asteroids and collecting samples, an entirely wasted mission, which is not a great thing when we want to be able to do this scientific research on the dust that comes back. So hopefully they'll be able to figure out some way of reducing the loss so we can at least get something back and study it. But yeah, that's a pretty sad situation to be in. Okay, I think I've got a question there from Jeff. Can you demonstrate something using geometry but not mathematics? Oh, sorry, you were dealing with a flat earther the other day. Well, funny you should ask that, because I was actually going to talk about this and a bit of the history of mathematics. When we think about maths, we have a very decimalized thought process when it comes to maths, because that's how we've all learnt. We've learnt in base 10 and we've learnt to do things. But the ancient Greeks didn't necessarily think in that way. When mathematicians like Archimedes were figuring out their principles, or Pythagoras was figuring out his theorem, you know, the square of the hypotenuse equals the sum of the square of the other two sides. They weren't doing that with numbers per se. They were doing that with straight edge and a compass. So if you get a line, you can break that line down into smaller components using a compass. And by drawing circles that surrounded lines that were drawn in certain fashions, you can draw a right-angled triangle. You can draw a whole heap of other shapes, and you can measure them using the compass in terms of the units compared to each other side. And that's what enabled Pythagoras to come up with his theory. So, in a sense, whilst it was still maths and it was geometry, numbers weren't actually necessary, although we ended up with a Pythagoras' theorem which uses numbers, in a sense. The way to get there wasn't so much about numbers. But that also leads us into the concept of number lines, which gets us back to why things like complex numbers are still actually existent numbers. They're not imaginary, unlike the name that most people want to call them suggests. They are real extant numbers, and they have to be, because otherwise our number lines don't work properly. So yeah, if you want to get down to the nitty-gritty of it, a lot of maths was originally done in the realms of geometry, especially higher level maths, and that was done without the need for effectively a number system. So Nerdy says, can I quickly explain stochastic gradient descent? No, I can't quickly explain that. Sorry, Nerdy. Yeah, I will count that as a stumping, because I don't think I could quickly explain that, but quite frankly, I'd probably get lost in the middle of it myself. That's how the it's all Chad Hall. That's how Principia was written. It's all geometric, because geometry is such a powerful tool in and of itself, without necessarily having actual numbers. Has anyone ever convinced a flat earther that the earth isn't flat? Yeah, no, it certainly has happened. There are videos where Conspiracy Cats was interviewing flat earthers who'd been convinced by arguments that the world wasn't flat, that they were wrong. So it does happen. I mean, not all flat earthers are stupid. Some of them are just ignorant, and they are fearful of what they conceive as authority figures. So it's like not all religious people are stupid. On the whole, most people are at least average. That's why we have an average level of intelligence. Or they're at least somewhere close to the average, because the way the bell curve works, they might be a little under it, but not a lot. You've got to go a fair way out to get the people who are at the extremes. So, on the whole, most people aren't that stupid, or not stupid at all. It's just that indoctrination and fear of things that are hard to comprehend can make people believe things that just aren't real. Yeah, you can ask me chemistry, Paul. Thank you so much. Thank you so much, Paul. If you expose ethanol to air, no. Chemistry is one of my worst subjects, unfortunately. I honestly couldn't tell you. One day I'm going to do one of these with Mero in here with me so she can answer the chemistry questions, because I am absolutely dreadful at chemistry. I can't even remember what the chemical formula for ethanol is. I would assume you'd end up with water and water, carbon dioxide, and something else. But I couldn't tell you what it is. You'd also end up with a vinegar, because you'd a vinegar substance, something vinegary. So probably not water, probably a mixture of water and an acid, hydrochloric acid? No, not hydrochloric. Acetic acid, is that right? Is that what you end up with in vinegar? Yeah. Ethanoic acid. Thank you, Paul. Yeah. So, Grumpy Old Dude, what amount of carbon is needed to change iron to stainless steel? That would depend entirely. hang on. No, trick question. Yeah, your grades of steel come about because of the amount of carbon you put in it, but generally stainless steel isn't just the level of carbon within it. I believe there's other things added into the steel to create, and I honestly couldn't tell you what it is, but yeah, I'm not sure. Not being a metallurgist, like I said, it's chemistry. You guys are going to actually screw me over with chemistry, because again, steelworking is chemistry. I'm losing track of the questions you guys are asking. Here is a tough one. What was the reason that Dave gave for his yoga ball exploding? It was something to do with the dog playing with it, I believe. You know, the dog had been playing with it earlier and it weakened it. I think it was because he had sex on it previously, but that's just my personal opinion. I can't prove it one way or the other, and I don't think anyone could. Yeah, a waste of wine. Is vinegary really a word? Great. Yeah, something can be vinegary, I would assume. There are different types of vinegar. Most of them would be some are all acid based. So yeah, I probably normally ethanoic acid because they're usually derived from wines, so they're usually distilled. So yeah. So Chattel, iron steel phase diagrams are interesting. Remind me to later on Twitter. Okay, Chad, I will, because it's fascinating. Something I don't know. 10% carbon for stainless steel. Yeah. Aren't some of the stainless? Isn't nickel added to some of the stainless steels to help with making them not corrode as much as well? I could be wrong there, but yeah, like I said, I'm not a metallurgist and I'm definitely not great at chemistry. It's one area where you guys are going to stump me all the time because I'm struggling in chemistry. I struggled in chemistry in high school, mostly because I hated it. I'm way more okay with it now in terms of I don't hate it anymore, but it's certainly not my favoured subject. Yeah. Yeah, I'd rather say vinegary to this taste of ethanolic acid. Okay. So, Paul, your answer should be... as long as I've done my arithmetic okay in my head, should be 25, because you get because obviously multiplication happens before subtraction, so you do the brackets first, so it's 2 times 4, which is 8, minus 3, which is 5, and then all of that multiplied by 5, which should be 25. And not everyone's going to believe me on that, but that's how you should be doing it. There are times when the order can be confusing because effectively subtraction is the addition of negative numbers, and division is multiplication by fractions. So yeah, sometimes that can get a bit confusing, and you have to think in that format to work stuff out. So yeah, they're essentially in the purest form of maths, there is not really any such thing as a subtraction or a division, because, as I said, you add a negative number and you divide by a fraction. You multiply by a fraction, because that's the effective way that these things actually work, and that helps you keep the order of operations more in line than if you're having to think about, oh, do I do addition or subtraction, or do I do the division or the multiplication here? Well, if you actually convert it all, it doesn't matter. because the order of operations for a multiplication don't matter, and the order of operations for addition don't matter when you're just talking about additions and subtractions themselves. It's the other stuff that gets confusing. But the way to make sure you don't confuse people with order of operations is use brackets. Please use brackets, people, when you're defining an equation, because that keeps it clear for everybody. Using chemistry, what's the ideal way to make a margarita? As I don't like margaritas, and you're asking me chemistry questions again, I have no idea. Shaken, not stirred. Does that sound better? Please excuse my dear Aunt Sally. Okay. All right. Okay. Bye. Love ya. Yeah. BIMDAS, or there's alternative ways you say brackets, indices, multiplication, division, however you wanted to say it, or BOMDAS. Yeah. It is typically the way these things are taught to us, but the order of operations is actually a little bit more complicated than that. How would I define knowledge? That's a good question, Nerdy Rodent. I think... Oh, God, that's an interesting question. Knowledge is a collection of the things that we know. Knowledge doesn't necessarily have to be factual or accurate. I mean, I'm sure Trump has a lot of knowledge. Most of it's probably wrong, but it's still knowledge. It depends on whether you're defining knowledge as things that are accurate, that you know to be true, or whether it's just things that you in general know. Knowing a heap of trivia might not actually be factual, or it may be very subjective and not objective. But you still know something, so it's still a form of knowledge. I'd rather, if we're going to rate knowledge, I'd rather rate knowledge on how factual that knowledge is, and I think that's probably a more important aspect of knowledge, is how factual it is. But knowledge itself doesn't require it to be factual. What's an equation? An equation is basically a set of operands and descriptors that are put together in such a way as to help us derive a result. So operands and descriptors. So our descriptors in many cases would be numbers, or they could be letters if we're doing algebra, and the operands would be things like division and multiplication, or square roots, or whatever else you want to do. So yeah. The order may not be a thing down under. No, BIMDAS or BOMDAS at all. I think BOMDAS is the more recent things. I mean, I did my most of my primary school and high school in the 80s. So these terms change over time. Even the way we're taught these things is changed. So I think BOMDAS is the current way of doing it, but it used to be BIMDAS when I was doing it. More of a philosophy question than a science maths question. Okay, Jeff, what was that? I seriously think that Trump doesn't care about the truth. He says what he thinks is advantageous for him in a situation, completely indifferent from whether it's true or not. Oh, yeah, I had 100% agree with that hot swatch. Yeah, he's certainly out to say the things that support him, but it doesn't mean he doesn't have knowledge. I mean, his level of accurate knowledge would be fairly low, would be my guess, except for in maybe certain fields. I mean, he's not necessarily a stupid person. He's an ignorant person. There is a difference there, and his ignorance portrays itself as stupidity in the world of politics. and for a lot of other shit that he does. So, yeah. Oh, the one nerdy ass is more thingies. You're a 70s child, nerdy, see whatever schools were doing then. Probably BIMDAS, but it also depends on the country, because different countries use different definitions for it. It's mostly there to get primary school kids, as they're starting to learn about functions, to do them in the right order, because the order of operations is important. But as you do higher level maths, you learn these equivalence things, and but order of operations is still important. But you also learn that the order of operations, it's one of those things where it can become confusing for people doing them. So in that sense, it's always a good idea to put brackets in, because that actually highlights exactly what you meant in your equation. So yeah, I had another thing that I was going to bring up. Now, anyone who watches SciShow would have seen this, but the Purdue University engineers have developed a new white paint that keeps surfaces up to 18 degrees Fahrenheit, and I'm reading from the article and my brain's not letting me convert the temperatures at the moment, cooler than their surroundings, almost like a refrigerator, but without using any engine. Well, not like a refrigerator, but it's basically what they've done is, but in the past, reflective paints for keeping things cooler have relied heavily on flecks of like metallic substances like aluminium or iron in them. Well, generally not iron, because it would rust, but most likely aluminium, to give them a more reflective surface to reflect back more heat. The problem with this has been that the aluminium is really, really good at absorbing UV radiation and warming up. So whilst you can get a bit better reflection from it, you also get it absorbing some more heat as well. So its effectiveness hasn't been that great. But the new one is made from different size and shape flecks of carbon. And the carbon's not quite as good as absorbing the heat from the UV, so it's actually 5 to 6% better than the metallic paints at reflecting the sunlight and the heat, which is what keeps it cooler. So when they're saying 18 degrees cooler Fahrenheit, it's probably not that much better than the metallic paints. It's probably only a handful of degrees better, but it is still significant. Overall, it's significantly better. And these types of paints can, you paint a roof with this type of paint, and you're keeping your whole house that little bit cooler, and that's less air conditioning you have to use. So it's a really good thing for the environment, and there's lots of ways we can use this in industry to create things. I mean, for example, you don't want your footpath to warm up too much so people can walk around barefoot and not burn their feet in the summer. Paint your footpath in this paint. It's going to reflect over 95% of all the energy from the sun, so the paths aren't going to warm up as much. It's a great idea. Okay, I will go back and find out what people have been saying. Why do some trees turn yellow in fall and others turn bright red or dull brown? I don't know that, do you? This has probably got to do with the chemical makeup of the leaf itself. I mean, most leaves, well, all leaves contain a variant of the chlorophyll molecule, so that the trees can create the sugars that they need. The exact combination of chlorophyll to other chemicals within the tree that cause the sugar creation is different for different plants. So my guess would be, and it is a guess because this is again biology and chemistry, my guess would be that those different combinations, when they dry out, turn slightly different colors. But it could also be to do with the exposure of those particular leaves as they dry out to fall off to the sunlight and the angles of the sunlight. So the more sunlight you get on the leaf, the obviously the more burnt orange they get because they've been dried out even more, and it'd also be the timing of when the tree actually gives up the leaf, because it's got to the point where it can fall off. So the longer they can stay on the leaves, the darker color they'd end up getting, because what it is, because of the sunlight on them. So yeah, there's probably a mix of all of that, but yeah, well, the different colors slightly absorb different spectrums, so as Sammy has said. So yeah, it's important. I mean, it doesn't have to be that that leaves on plants have to be green. That's not a requirement. It's just a requirement that the leaves themselves can absorb enough sunlight to get enough energy to create the sugars. So if you have plants on, say, a red dwarf star, you'd probably find that to get enough sunlight, most of the plant leaves are going to be somewhere closer to black, so they can absorb enough of the radiation to get enough sugars for the plants to survive. Whereas on our world, there's enough light getting in per square meter, and I honestly, off the top of my head, I can't remember how much it is, but it's a shit ton, that the leaves don't have to be as efficient. So you go for a chemical combination that makes the easiest amount, makes it the easiest for the plant to produce the sugar as well. So if you don't have as big a requirement for absorbing the sunlight's energy to produce the sugars, you can go with an easier to process set of chemicals, easier chemical reaction to occur, and therefore keep your energy requirements down and still get the sugars that the plant needs. So it's a mix and match, and green seems to be in the greens versions of chlorophyll seem to be the way that plants have gone on our planet. Not all plants. There are quite a few aquatic plants that still absorb sunlight in the shallows that use different colours. So it's not consistent, but most land plants seem to have gone with the green. Okay. If animals can talk, which ones would be the rudest? Yay, Spooky! Awesome question. I don't know, but I believe elephants have a wicked sense of humour. They will play tricks and stuff on their keepers, steal things and hide them, and they almost have a way of laughing in similar ways to that primates do. So possibly elephants would be the rudest. I mean, who's going to argue with it? If an elephant calls you a dumbass, you're not going to say, well, you're a fucking dumbass to them, not if they're in reach anyway. So, yeah, maybe elephants, because they got nothing to fear. Not to. It does boil down to the plant's plant DNA. Well, yeah, there's an RNA there. So it does with the plants. Never again. But in the same way Sammy's been explaining to you, the color changes happen anyway because the plants go into shutdown mode if they're ones that drop their leaves. I mean, if they're evergreens, they don't do that at all. They just keep their leaves up. But if they're going into shutdown mode for heading into winter, they stop performing that. The sun dries out and breaks down the chlorophyll. So so the green color will disappear. But depending on the exact chemical reactions that the plant uses would affect what colors they turn, how long the plant actually hangs onto the leaf, which has got to do with the leaf design, and where they are in the world because of the amount of sun they might receive, as that is going to actually change the way that the colours come up. So yeah, but yeah, pretty much what Sammy has said. Honey badgers, yeah. Well, definitely one of the rudest animals is badger. Definitely nerdy. Um, 37 years IoT experience, 27 owner of a small software company consulting firm. Depends on how the idea is set up, Nerdy Rodent. Oh, okay. So I missed a question somewhere that I'm guessing Nerdy asked. Or someone did. About computers. I'm sorry, I've got no idea where that is. Coding questions. Spaces or tabs for indentation? Yeah. Tab is so nice for being easy to get a space out, but tab is not consistent in applications. Different applications will process tabs in different ways. Some have set number of character spaces that they will move things. Some move them up to put things in alignment with the text up above or whatever. So if you're creating a text that is going to be spread out between different apps, then perhaps tab isn't the best way in using spaces. However, there is a proviso to that in that all new word processors tend to use differing fonts, and fonts have different levels of kerning, which is the difference the gaps between the letters, etc., plus the sizes of the letters themselves. So spaces, because of the kerning of the font, can be different lengths. So again, you can have problems with trying to lighten things up. So yeah, it's why we need consistent formats and people need to make sure they have the right fonts installed to be able to see the fonts. That's where things like PDF files come in handy, because everything's contained within the PDF. So when you send a PDF file to somebody, it's going to look the same to them as long as they're using the same PDF reader as you did, that it did for you. So it's kind of why I like PDFs. But yeah, I am probably for spaces because I do a lot of stuff that requires use of text files in processing, especially when you're programming and stuff like that. So I'm probably more in favor of spaces because they work in more text editors, but I think it comes down to personal preference. Yeah, we all know the speed of light. What is the speed of dark? Well, there isn't, because dark is just the absence of light, so there isn't anything to make it have a speed. I mean, effectively the speed of dark could be more or less infinite if you're talking about how fast dark will encroach when the photons disappear from a location, because it is technically instantaneous. There's no more photons in an area. That area is no longer able to reflect light, so speed of dark is instantaneous. But dark isn't a natural thing. So, I mean, we use the term dark, we use etc. But from a scientific perspective, it's not a thing. So there's no speed of dark. Yeah, Jeff. Badgers are only rude when it comes to Disney Star Wars. Yeah, I will agree with you with that. Never Again thinks dolphins would be the most rude. They laugh and laugh at us all the time. Yeah, but I mean, depends what you mean by rude. I mean, dolphins are incredibly sexual beings. Where we think we can be quite sexy and want to have things. I mean, dolphins fuck each other in the blowhole, for fuck's sake. I mean, they're amazing creatures, but dolphins who've got used to humans will get erections. The male dolphins will get erections around humans and play up against humans in a sexual manner. There was a case of the woman who spent several, I think it was a couple of months living with a dolphin in what was built as a wet house. And this dolphin grew feelings for her as she did for it. And they were basically in a kind of bestial relationship. And for the life of me, I cannot remember her name. I mean, there was no sex involved per se. But she got to the point where the dolphin's erections were stopping them from working properly. So she would have to relieve the dolphin of its stress. So, yeah, yeah, it's one of those things. So, yeah, rude as in sexual. Yeah, I'd go that with dolphins. Yeah, all cats. Yeah, your cats are rude anyway. Yeah, they'll put their ass in your face. They don't care. You're just the thing that gives them food. But I mean, unless it's a big cat, I don't think you have too much to worry about. And cats are more scared of you. Small cats are more scared of you than you are of them. So, step on your keyboard and spill your coffee. Dark is not a natural thing. Dark is not a scientific thing. Never again. Dark is just the absence of light. And if we're talking about the speed of something, you actually have to have something that moves. In the case of a light, it's a photon. There is no such equivalent for dark. Dark is just the absence of those photons. So effectively, it can't have a speed. Yeah, oh yeah, never again. Dolphins are probably more sexual than humans. Sorry, Jeff, I didn't mean to ruin Flipper. Between cats and dolphins, you choose dolphins because their bits are barbed. Aren't cats' bits barbed as well? Shadows move as fast as light. Yeah, effectively, but a shadow is a gain, a depletion and absence of photons. So, again, it's not an actual thing that it is a thing. I mean, if you're going to say that you can... the problem with this kind of thinking is that you can... is you start looking at superluminal effects. You can start looking at things that are superluminal effectively as being actually superluminal, and superluminal means faster than the speed of light. For example, if you shine a torch, if you shine a light at something, the photons that move out from here to the surface that you're hitting on move at the speed of light. But if you scan, so that sort of way, across something and you're far enough away from it, the effective movement of the line across, and you can't see what I'm doing, the effective movement of the line across the surface, the light across the surface, can be faster than the speed of light. But the photons themselves haven't moved faster than the speed of light. It's that illusionary effect of the thing moving. And in this sense, the speed of dark is an illusionary effect because it's just the absence of light and the things that moved with the photons. So, yeah, how fast could dark be? Well, yes, the speed of light, but technically it could be faster in the same way as you could move. So that's where you have a complicated things. I mean, to have a speed, you actually have to have something moving, and the dark itself does not move. It's the light that moves. Their bits are not barbed. Cats' bits are barbed, but not dolphins. Yes, that's what I thought. But I was taking your word for it because I wasn't sure. Yeah, there's documents about her, but I honestly cannot remember her name, which is absolutely bugging me. But yeah, she gave the dolphin a hand job, and he was very grateful. Apparently, they were really good mates by the end of this. So yeah, she'd actually read stories to him and things. It was kind of cute in a way and very disturbing in others. But yeah, dolphins are quite sexual, and they'll be sexual with humans if humans will let them. It's one of the problems they have where humans go swimming with dolphins, is that the dolphins can actually get quite amorous with the humans. It's why it's often not recommended to go swimming with dolphins, because dolphins who are used to being with humans will get amorous and everything, and a dolphin in the water can hurt you significantly. You're talking about an animal that a lot of them have more mass than most humans and are way more agile than us in the water and can really, really hurt you. I have no idea what you pulled back from there, Sammy, but I'm sure it was a tad rude. God is only the absence of science. Yeah, well, that's fair. So the speed of God is nothing because he's a nothing. Yep, I'll go with that one, Sammy. Which animals have the most weird genitalia? Yeah. There is a species of shrimp where when the males mate with the female, their penis, well, equivalent thereof, becomes lodged in the female, and then the female basically grows their own skin over the male, so the male becomes permanently attached to the female. So mating is a lifetime experience for these animals. Yeah, it's kind of fascinating. So yeah, that's probably one of the weirdest forms of genitalia. But I mean, you're talking about the animal kingdom. The animal kingdom is incredibly weird. Female hyenas basically have a penis that they give birth through. That's definitely weird, but that's because the testosterone levels in female hyenas are incredibly high as the males, which is why all hyenas are fairly aggressive and well built. But it's a survival trait for them. But it means that it's incredibly dangerous when the female hyenas have sex and or give birth, because they're basically giving birth through a penis, which is yeah, a tad disturbing when you think about it. The dolphin letters in the penthouse. Carry your anti-dolphin spray. Okay, Jenny, what? Oh, if you shine two lasers precisely centered at each other, can they cancel each other out? Oh! See, that would be really, really complicated, because whilst laser light is more coherent than most of the other light, as in it stays mostly it stays more together and spreads out slower than other lights. It still spreads out, and the wavelength of the light in the particular direction is such that lining them up would be your difficulty. But effectively, if you could guarantee that the two lasers were out of sync by 180 degrees in their waveforms, yes, technically you should be able to cancel out one laser with another. Its light is no different to sound or ocean waves in that respect. Two beams at 100 of the same amplitude and frequency at 180 degrees will cancel each other out. But lining up two lasers to be able to do that, I would imagine, would be incredibly complicated. I'm probably not the best person to ask that of. Probably almost a doctor would be the ideal person, because he is pretty much a laser expert. But yeah, I would imagine you should be able to cancel them out. Alright, where did I get to? What will he? Ask Ken Hovind about whales. Oh, whale penis. Yeah, he knows all about whale penis, does Ken Hovind. Yeah, dolphins are aggressive and horny. Unfortunately so. They are very, very sexual animals. Why doesn't ice cream have bones? Because it wasn't effectively a living creature beforehand. It also depends on the type of ice cream. Not that it would have bones anyway, but I mean, most ice cream is a milk-based product, so it wouldn't have bones. Like, yeah, spiders with detachable peni. There's a type of grasshopper that's penis is actually longer than its body, which there's also a couple of butterflies that are like that. They actually have penises that curl up, and when they extend, they're longer than their body. So just imagine how dreadful it would be being a female butterfly or whatever. You know, those enormous penises, you'd be able to taste them out the other end. How does a laser microphone work in layman's terms? Okay. But my guess, as far as a laser microphone, if you would be using a laser emitter and a sensor, and the laser pulses would be able to detect the vibrations in the air if they're sensitively enough set up. And then you convert the pulses that are picked up at the other end into a signal in the same way as you electronically pick it up from a vibrating membrane in a normal microphone, or if you're using a condensed mic or whatever. It depends on the type of microphone you're using. But yeah, you can. That would be my guess, but never actually having pulled one apart, I don't actually know. Don't echidnas have four-headed penises? Yeah, again, biology and chemistry, Jeff. I actually don't know. Possibly our wildlife in Australia is odd. Do photons have mass? Great question, Jen. See, technically, photons have no mass. Otherwise, they wouldn't be able to travel at the speed of light. But photons have energy. They have momentum and energy. And anytime you have energy, energy is equivalent to mass. So to say that effectively photons have no mass, but from the point of view that they have energy and energy is mass, yeah, they do have mass. So yeah, it's one of those odd things. But photons are also dual in nature. They're both a particle and a wave, as well, basically everything is. So effectively, a photon's mass is zero. But there is a small amount of energy involved, and wherever you have energy, you have mass. Must remember, Jen takes all questions seriously, or appears to. Yeah, I take questions seriously. They use them on ghost hunting shows. They would be excellent for spying then. Yeah, maybe. Not necessarily simple with the photons. It's one of those things in physics that is, yeah. We have certain particles like photons that should have no mass, or if you have tachyons, they should have negative mass. I suppose you could say that it is conceivable that the actual photon's mass is negative, but the energy it has from the speed it travels at gives it a net mass of nothing, which is quite probable, because there has to be a mass from the energy it has of moving. But yeah, the interesting thing about that is, if that were the case, the fact that we can slow down photons, we should actually be able to prove that a photon had a negative mass when it's slowed down. And I don't think that's been the case when we've been able to slow down photons, but it would be one way of explaining it. But yeah, it's definitely an interesting question. Spooky. Is gravity made of particles? Now there's an awesome question. According to general relativity, gravity is what energy and mass do to space-time. So large amounts of energy or mass, and got to remember that mass is just large amounts of energy, curve space-time. And then objects within space-time move in what is effectively straight lines. To us, they look curved and bendy, which is why things orbit. But they are straight lines to them because space-time itself is bent by the mass that's in them. In quantum mechanics, there should be a transference particle within quantum mechanics called the graviton, which is like the photon but for gravity. So in that sense, in quantum mechanics, there should be a particle that is the transferal of energy for gravity, because gravity, there is energy loss in gravity. It's why we have gravitational waves and things like that. So in theory, there should be a graviton, which is the transferring of force particle within quantum mechanics. But if gravity is just a geometric anomaly because of mass and energy, then the graviton isn't necessarily needed even at the quantum level, because you've still got that geometry that works. It's just that at the quantum level, those geometries are so small because you're dealing with so little mass that you can virtually write gravity off, because the force of gravity is so small. Is gravity a force? Gravity is what we call a fictitious force. Technically, gravity is not a force. The fact that objects want to keep doing what they're doing unless acted upon by an external force is what gives us the appearance of gravity. So, because of the way that space-time is bent around large objects, the natural incline is for things to move around it. Then you've got atmospheric drag that pulls things down into trajectories that make particles fall towards the center of each other's gravity. But the center of mass, I should say. But this is a fictitious force. There is no actual force doing it. This is purely the geometry of space-time itself that causes this effect. So this is why gravity is a thing, in that it is the fictitious force that comes out of the bending of space-time. So gravity is real, but is it actually a force in the same way that the other fundamental forces are? Scientists are of two minds of that. A lot of the discussion now is that we just call gravity a fictitious force, which the fucking flat earthers love to bits, because they go, it's not actually real. Yeah, it's fucking real. A fictitious force doesn't mean that the effect of that thing, the thing of gravity, isn't real. What it means is, in terms of how we normally describe forces in nature, gravity is not the same. Is it fair to call gravity a result? Yeah, it's a result of the shape of the bending of space-time. What is the shape of the universe? That's a damn good question as well, Nerdy. Wow, you're on fire tonight, Nerdy. We think the universe is mostly flat from at least our region of the universe. This is the problem. Our universe is defined by the light horizon. So how far we can look into the universe is defined by how long it's taken the light to reach us from the first stars. And that's what we see of the universe. But the universe itself will be bigger than that. We know it's bigger than that because it's expanding faster than light can move at the outer edges. So we have this thing that we know the universe is bigger than what we can see. So what we have is our visible universe. As far as we know, that from the measurements we've been able to take, the cosmic background radiation and of the movement of stars, and galaxies, the visible universe is flat. And by flat, I don't mean like a pancake. It's still a three-dimensional thing, but it doesn't curve around on itself. Now, there is a problem with this, and it's the same problem that flat earthers having, looking at the earth and go, see, I can see it's flat, when it isn't. And that's perspective. We don't know how big the universe is. If the universe is big enough that the little tiny piece of the universe that we see is just a little tiny arc second of a greater curved space that's spherical or whatever, we would not be able to tell the difference between a flat universe and a completely spherical one, or whatever other shape it might possibly be. So whether the Earth is flat or curved or whatever depends on how large the actual universe is. So effectively, we think it's flat by what we can see of the visible universe, and the visible universe we can see is 96 billion light years across. Now you're going to say, how do we see light from 48 billion light years away? That's because the universe has been expanding over the 13 billion years and has expanded faster. So that first light that we see is now that far away from us. We know that is from the rate of expansion. But at the point when the light left to come to us, it was a lot closer. So that's how come we know the universe is larger, but we are actually only seeing out the 13.8 billion light years away from us. That is the max distance that light could have actually travelled, even though those objects are now much further away than that. So we know that the universe, the visible universe, is that big, but the universe itself could be a lot bigger, which totally screws up our chances of actually really knowing what the shape is. But if the universe isn't much bigger than what we see, then yeah, the universe is flat. If it's a lot bigger, we just can't know. There is no way we could ever know. Where did we get to? Is there such a thing as anti-gravity? Oh, now, people stop asking me good questions. All right. If Einstein's theories, if general relativity holds true over the long term, because general relativity will be true within the confines of what we can see of the universe, except for there are some problems in cosmology, and we can solve them in various ways, but they are problems that we have to figure out a way to solve. But in general relativity explains how our universe works incredibly well, so well that it has passed all these tests over and over and over again for the things we see furthest away to things that are up close. But there are issues. One of those issues is the expansion of the universe and the fact that it's accelerating. And the other issue is the orbits of stars and galaxy clusters. Because in general, when you're dealing with something like the sun and the planets in a solar system, the things that are closest to the center point, which is where most of the mass is, i.e. the sun, 98.9% of all the mass of the solar system is in the sun. So that's where most of the mass of the solar system is. So anything that's closest to that is the thing that moves fastest, which is what you'd expect, because they've got, they're closer to the sun, so the sun's they're closer to the gravity well, so they're going to move faster. And so you'd expect when that translates out to the galaxy, things that are closest to the center of the galaxy, where most of the mass is, like the supermassive black hole and a huge number of huge stars, way more than there is, even though there's more area in the outside, there's way more mass in the center of the galaxy, visible mass, stuff that we can see, than there is in the outskirts. And yet, the stars in the center, on average, move slower than the ones further out. And it's totally opposite to what we think it would be, unless there is more mass in the outer regions of the galaxy. Which is why we think dark matter is a thing, because we need the extra mass in the outer reaches of the galaxy to make up these differences. And this doesn't just happen in galaxies, it happens in galactic clusters and superclusters. The movements of these things don't make sense without adding in extra mass, but we can't see this extra mass. So dark matter has to exist. Dark energy is a similar thing. A dark energy is an energy that we think exists, which is what's helping to promote the expansion of the universe. And it also, because it's an energy, provides us with extra mass as well. So whilst it has a repulsive effect like an anti-gravity effect, it also gives us more mass, so that can help with some of these other problems. So for general relativity to explain the universe that we see, we need these two other things. There have been other proposals to modify general relativity so we don't need these things, but so far none of those have stood up to all the tests we can throw at them. Adding these two items of dark energy and dark matter to general relativity stands up. It's frustrating because we can't see them, we can't prove that they're there, whatever, but they seem to have to be there. And that's the problem in cosmology at the moment in a nutshell. Now, if this is right and these things exist, then yes, there is anti-gravity because dark energy is effectively anti-gravity. So yes, there's quite probable that there is such a thing as anti-gravity. Okay, yeah, we should think of gravity more as a term that describes the effect bodies have in the geometry of space-time. That's exactly right, Sammy. Yeah, more of a thing than a force. Are we in the center of the universe? Good question, nerdy. We are all in the center of our own visible universe. If you look out at the night sky, you will see out to the same distance in every single direction. Well, you can't see all the way with your naked eyes, obviously, but if you could see all the way to where the furthest light has come from, you would effectively be in the middle of your own visible universe. However, we have no idea how big the universe is. So, where are we in the effective entire universe? No idea. Probably not in the middle of it. It may not have a middle. It's quite conceivable that the universe itself is actually infinite beyond what we can see, or is curved so much, as I said before, that it wraps around in on itself, in which case there is no middle to it because it just constantly wraps around. In which case expansion of the universe would be explained by the fact that this bubble that we sit as a membrane on is just expanding and expanding and expanding and expanding. And that just might be the nature of how universes work. Okay. Yeah, there is no center everywhere, is the center, more correctly. Christians are the center of their own universe. Oh, so much so, Sammy. What is the SRY gene? Okay. The SRY... Yeah, why biology, Jenny? Thank you so much for the biology, but why biology? The SRY gene is a gene on the Y chromosome that is activated to start the process of male body forming. If a zygote or a fetus which has XY chromosomes but has a non-active SRY gene is developing, they will develop female because their SRY gene does not work. So that they will, for all intents and purposes, develop female. Often, usually infertile. Although I believe there has been some cases of fertility in SRY children. I'm not exactly sure how that works. Not a biologist. But yeah, the SRY gene is one of the activators that selects for being male or female. We think of it as being the Y chromosome that does this, but really it's only a few of the alleles within the or chromosomes within the Y chromosome that actually affect what biological sex somebody is born as. So yeah, that's what the SRY chromosome or gene is. Jen, yeah. What do you think of Roger Penrose's idea for universal aeons, roughly end start end loop? Oh, okay. I guess that's possible. It was certainly a big thought that the universe would expand and then gravity would pull it all in and crush it all up again and then expand again. So like a bouncing universe, as it were. And that could have happened for eternities, and we're just one of the cycles. It does appear, though, that the expansion of the universe, as it seems to be accelerating, would suggest that that's not going to happen. My personal thought on this, and I sort of touched on this the other night, is that the start of the universe comes out of the quantum fluctuations. So that given enough time, you're always going to have a point where the fluctuation in the quantum soup of particles popping in and out of existence eventually gets out of balance to the point where you have an expansion of matter within the multiverse, so to speak. This is probably something that continuously happens, although on timescales that aren't perceivable by us. So it is quite possible that whilst we live in this bubble of this universe that's created for us, within the greater universe or multiverse, depending on how you want to look at it, this sort of thing is happening all the time. Now, if there isn't actually a multiverse per se, but we're all on one great big expanding balloon of things that happen, perhaps that balloon expands because a new area, another little big bang happens and starts pushing the balloon out to be the balloon. I'm using a balloon analogy to make it bigger, and that helps to promote the expansion of the universe. So the expansion of the universe is accelerating because there's more area for these things to continue happening, and that in turn makes it happen more, and thus the universe expands continuously. There might be a point to which point where that stops happening and it can't happen anymore, and the universe sort of pops, which would bring about the end of the universe as we know it. And from what we can tell, we can only tell the age of our little part of the universe as well. The cosmic background radiation is unique to our visible universe. So beyond that, we couldn't know if there were sections of the universe that were older because we can't see into them. But yeah, it's kind of fascinating. And I think I went off track with the questions. So there could be loops like that, but I'm more keen on the idea that the universe is cyclic in the sense that big bangs happen all the time, which I'm good with. Hi, Ilya. And thank you, Ian Davenport. I try. Okay, where do we get to? What is a Matroska brain? Sammy. Okay. Effectively, a Matroska brain is basically, well, we think of evolution as, the starting of life, complex amino acids coming together to form the first RNA and DNA, and then life brings out. But technically, it's possible that in space, you could have a chemical structure come together that is basically just a brain. It just forms and from the matter that's in the universe and just creates this brain. Now, one of the concepts that comes along with this is that in the start of the universe, perhaps what happened is that a brain just formed. Randomly from the quantum fluctuations, a brain just formed in space. Well, not space, but in the multiverse, as it were. Within that brain, there is thoughts and things. It's a complex computer system, much the same as we are. And that brain can have dreams and imaginations. And we could just all be part of a giant Matroska brain, dreaming and imagining. We're all thoughts in this brain that's there. We are a brain. We are all one brain in a vat, effectively. That's was created by whatever form caused that to happen naturally. So a Matroska brain is just a brain that forms naturally on its own, either within our universe or is the universe per se. But I mean, this comes down to solipsism, and I think it's irrelevant because regardless of whether or not we actually there is a Matroska brain and we are part of that brain or whatever else is irrelevant because we have to deal with the universe that we actually experience. Because we can't deal with any of that other stuff. If we encounter a Matroska brain out there, a brain that just formed in the universe, that would be fucking awesome. But it's still just another life form in that sense. If we're part of the conscious thoughts of a Matroska brain, then it doesn't make it God, it just makes it our universe. And we're just its dreams and its thoughts. Which, you know, in some ways is kind of beautiful, but irrelevant to us. Oh crap, you're right, that's a Boltzmann brain. Ha ha ha! Well done, Sammy. Yes, you're quite right, that's a Boltzmann's brain. Screw you. Yes, okay, that's me being an idiot. Scammer says, I'm not the center of the universe, I'm just the center of my observable universe. Yep, that's exactly right. Help, I'm just a dream. Yeah. Yes, it does. The Matroska brain is the concept of us actually engineering a brain that we could download our giant computer system that we could all download our consciousnesses into and live inside that. Yeah, basically we can create a star-sized computer and move our consciousness into it, which might be the way that a future version of our species survives in what long distant future, or might be just the way that some species decide to live because, you know, creating self-automating systems that can repair themselves and everything and putting us all into copying all our memories into an artificial intelligence where we can basically live forever and live multiple lives and go through it all the time. So yeah, having said that, we wouldn't know if we, for the same thing as the Boltzmann brain, the Matroska brain, we wouldn't know if we were already living in a society that had already done it. It's kind of matrixy in a way, but yeah, I honestly think these kind of things, that apart from as thought experiments as something we might do in the future, are kind of irrelevant, because if we do live in that kind of world, we wouldn't know. We probably can't know. And if we do it in the future, well, it's not going to happen in our lifetime, so it's not even something worth considering, I don't think. But yeah. Yes, you're right, Sammy. You got me because I answered the wrong question. But hey. Alright. Do spirits have weight? Well, this certainly does. Yeah, given that I don't believe in souls and spirits, then yeah, no, or irrelevant. In your opinion, has Trump done anything good during his presidency? No. I think Trump's been a complete waste of time for people in America. Yeah. I'm sure there's something somewhere along the line that the Republicans have done that has been good for America, but overall I think his scorecard is fucking dreadful. He's kicked so many own goals for them, you know. It's been good for the Democrats, I guess. Do unicorn farts have weight? Do unicorn farts exist? No. Do unicorns exist? No. So, well, I mean, unless, of course, you're going to say that unicorn is what they called rhinoceroses in the Bible, in which case farts are a mixture of gases. So, yes, they have mass and therefore weight. Of course, they're lighter than air, so they float, but buoyancy is actually a thing, but not what the thing that flat earthers think it is. But yeah, if you're going to say that the rhinoceros was the unicorn, then unicorn farts or rhinoceros farts have weight. If unicorns were real, their farts would have weight. What do I feel the great filter is? Okay. So Sammy Jenkins is asking what I think the great filter is. The way we think about alien life being out there is that if life was so easy to happen here on Earth, technically, given the right conditions, shouldn't it happen elsewhere in the galaxy? The galaxy has an awful lot of stars with an awful lot of planets. Some of them are going to be habitable. If enough of them are habitable, surely enough life has developed. Surely other intelligent life has developed. If there's other intelligent life, why can't we detect them? Surely they're giving off some signals. There are certain issues to this. One of those things is that the way we look for intelligent life is we're basically looking for signals that we would put out, like radio signals or laser signals or something like that. There is a range for these things. To get radio signals across the vastness of space, you have to apply a shit ton of energy into them. Generally speaking, the radio signals that we produce in terms of television and radio and CBs and people talking to each other or the internet, these aren't that higher powered. So whilst they have moved out, like radio's been around for around about the 100 years mark, so we've got 100 light years of radio signals getting out. Much further than that as they go, the signal quality degenerates and spreads out to the point that it becomes indistinguishable from the cosmic background radiation. So we get to a point where the technology required to detect those signals if another species is going to try and detect us becomes harder and harder and harder and harder to maintain. The reason why we can see things with radio telescopes that are a long way away is because these things are powerful, like pulsars and black holes. Which means you'd have to have an alien species aiming a powerful signal like that directly at us for us to be able to pick it up. And we as a species, well not that powerful a signal, but we as a species have only a handful of times tried to send that powerful a signal to a specific location in space. And that then requires that specific location in space to have life capable on it of picking up the signal and then replying. And remember, it takes... If the planet we're trying to send the signal to is 40 light years away, it takes 40 years for that signal to get there, and then another 40 years to get a message back, if they were looking in the right place at the right time to pick up the message we sent them, because we're not sending them all the time. So effectively, one of the greatest filters is just the size of the galaxy itself. It's immense. The distance between stars is immense, and that makes it really hard for us to pick up signals in the same way as it's hard for another species, if it's out there, to pick up our signals, for us to pick up their signals. They're going to have to be close enough to us that the signal doesn't degenerate, or they're going to have to have targeted us. And to target us is a big ask, because they have to detect that there's a planet here and then figure out that it's worth sending a signal to. And that's something we've only just sort of achieved the ability to detect planets to that level. Yeah, as Mike Rapp said, a planet 400 light years away wouldn't hear anything from us. It's actually a little shorter than that, depending on how you're listening for these signals. The way we do it with SETI, because they're not concentrating particularly on one area of space and looking for those signals completely, we're spreading out our search, we actually lose a bit more and can't detect it as well. So, but the other aspect that comes into the Great Filter is that whilst life is going to be probably ubiquitous across the galaxy, there's going to be life everywhere, would be my thought. If it happened here, it should happen other places. Life doesn't always tend to intelligence like ours. On our planet, we are the only species that has evolved to make things and do science and stuff like that. There are other species that are similarly intelligent to us, like dolphins and whales. They have a problem. They're in water and don't have dexterous digits to make things. Other intelligent creatures like elephants, who are on land, are again, they've got a dexterous trunk, but they don't really have the hands, and they can't do the fine motor skills to the same level we could to develop things. So it it took a freak of, because evolution's like that, it took us going down this channel of us climbing down out of the trees, moving out into the savannas, where we had to rely on getting bigger brains and becoming more intelligent and more social and more active to get that level of wonder and intelligence that enabled us to invent and do things to the point where we could be sending out signals and looking for them. Our planet has had life on it for nearly 300 million, evolved life, as in higher levels of life on it, multicellular, for about 300 million years. And it took until this last little bit of it for a species to evolve like us. Before that, we've had so many other species evolved and become very, very, very successful, but not do the science and build the radio telescopes and things like that we have done. This is not going to be a common occurrence. Evolution doesn't have a target. It is in effect not random, but it doesn't have an end goal. Humanity wasn't an end goal of evolution, and something like us is not going to be the end goal on other worlds. So you have this filter that intelligence isn't a requirement of evolution, and you have this filter of distance. So the chances of there actually being another intelligent species like us, even within our galaxy, is probably fairly low. There may be another one at the same time of us, but remember, we don't even know how long species like us survive for. We're fucking up our planet right now. In the geological time frame, if we go extinct in the next couple hundred years, that's it. We've hardly been here at all. We not only have to have other species like us evolve to make the same sort of technologies that we have, to be close enough that we can pick up those signals, but they also have to be in the same time as us for us to be able to share this. Otherwise, we just miss each other on the road of it all. And our universe, which could survive for trillions of years, is only 13.8 billion years old. And we took this long to evolve in it. We had to wait for the third generation of stars to have enough of the heavier elements to get life. And then that gives us only the last 4 or 5 billion years that life could happen in. And we know it takes a long time to get from single-cell creatures to multicellular creatures to creatures that might evolve intelligence like us. It takes a long, long time. Whilst there might be someone else out there in the galaxy as advanced as us, or more so, it's going to be rare. And to be in the same part of the galaxy as us, that's just too much to ask for. So, in my mind, that is the filter. Hi, epileptic skeptic. So where do we get? Yeah, so one popular idea is that advanced species would destroy themselves before becoming capable of conquering an entire galaxy. That is quite possible. Is Earth prepared for an alien invasion? No. If there's an alien species that has the technology to get to here, we're screwed. Because in all honesty, you're talking about a species which has mastered the use of antimatter or fusion and massive solar sails and high-powered lasers and stuff like that. So, yeah, no, we're fucked. They have to have all the same technologies that we have, but more advanced than we have to get here. And we'd be like flies to them at that point. Even if it's just technologies we know might be possible in the near future for us, that's still going to be significantly more advanced than us, that we may as well put up our hands and surrender straight off and hope that they're friendlier than we are. So where are we? Chimpanzees could have evolved to our intelligence, but their evolution took a different path. That's very true, because evolution doesn't have an end goal. Okay, Jenny, the moon gets further away each year. How far away must it be to lose its grip on... must be to lose its grip on Earth and be flung off and away. It's not very much that the moon moves out. It's only a couple of centimeters a year, and in the scheme of how far away it is and everything, and that's not very much. For us, for the moon to basically have enough inertial force from its orbit that it could totally escape its orbit and fly out, I think it has to be 2 to 3 times the distance that it is at the moment, and the length of time that that's going to take to happen is longer than it will be before the sun expands. So the Earth is not going to lose the moon before we are fucked by our own star, basically. I like the Silurians, Microraptor. I like the Silurians from Doctor Who. I think the thought of another species evolving to our level of intelligence. Yeah, I mean, it is possible. We know that the technologies we have in a couple of 100,000 years, if we went extinct tomorrow, but of course the planet won't go extinct short of a major catastrophe. Even if we destroying our destroying the Earth's environment and creating global warming, unless of course it becomes runaway and we become a Venus, is not going to destroy all life on Earth. Life will survive. We will have a major extinction event, which will probably include us, but life will come back again. In the meantime, all the things that we've created will fall apart, because if we don't manage them, they fall apart. We know that by looking at things that were in the past. So most of our modern constructions wouldn't last more than a couple of 100,000 years. Well, none of them would last more than a couple of 100,000 years. So what would be the evidence of us here? It'd be the things that we made that do last longer. Some of the plastics and some of the other things that would show up in ice cores, for example. So assuming we don't melt all the ice and the movement and things, but there would be notifications within the cores that we develop nuclear weapons on this planet and at a certain time frame, and we'd know that wasn't a natural future species that is intelligent as us would be able to detect that was a thing that happened. It is quite possible that we had intelligent species that evolved around with the dinosaurs, similar to us, that made certain things, and just the evidence of those things just no longer exist because of the movement of continents, because of just because of the passage of time that's destroying it. However, we haven't found any fossilized remains of any creature that looks like it could have had the cranial capacity to be like us. We've seen things that are getting closer to it, especially in some of the bird-like dinosaurs, but there's no actual evidence for it. But who knows? We might find something in the future and go, oh wow, they actually was some sort of Silurian. Yeah, it was about it was a bit longer than 3 billion years, but yeah, something like that. It was an immense amount of time, Microraptor, for life to become multicellular. What do I make of the high-end government officials that have claimed that we have already made first contact? Crazy liars or a distraction? Most likely a distraction, or liars, or conspiracy theorists in and of themselves. The reality is going to be that it is so hard and requires so much technology to get between stars, even if you end up with the possibility of faster than light travel, or a species that is so long-lived that they don't care how long it takes to get between the stars. The effort that it takes to get here would be such that they would either see us here and think, oh, they're a threat because they're so fucking violent and just not want to make contact with us at all, or they're going to want to make contact. And the way to make contact would probably not be with government officials. It would probably be with the scientists first, because they're the people who are going to speak the same language as them. Politicians are not the ideal people to talk to. when you're trying to talk to a alien species. I mean, we had enough problems communicating, learning languages of other races on Earth, as we, as we colonized, like England colonizing the New World and stuff like that. Going and learning the new languages was really complicated for us. But we had common reference. We could point to a tree and say tree, and they would have their word for tree, and we could learn it. And that because all humans had similar actions and similar things that we know about. An alien species may not. They may not even look enough like us for us to even have that in common. Or even the way that we communicate could be completely different. We're good with doing this with humans, but we know that dolphins communicate with each other with their clicks and whistles. And we know they have different sounds for different words and phrasing, dolphin words and phrasing, but we do not understand that at all. And we have lived on the same fucking planet as them. So the thought that somebody who is a politician would be able to understand somebody from another planet is just not going to happen. The people they're going to talk to are scientists, and they're going to use languages like maths, which is more universal. So yeah, it's bullshit. They haven't been here. Yeah, we'd be like the Native Americans when the Europeans first got to America. If aliens are not friendly, we might end up in a book called this To Serve Mankind. Yeah. There's no guarantee that aliens would be friendly. Quite frankly, I think they probably won't. Generally speaking, I mean, it seems to be a trait of the species that have grown larger brains within our on our world. It appears that predatory species are the most common ones to do that. I mean, elephants have large brains, but they're probably an exception to that. Most of the larger brained mammals tend to be predatory. Even birds are pretty much the same, tend to be predatory. There's no reason not to think that might not be the same on other worlds, and being a predatory species comes with that level of aggression to survive, because it's handy with evolution. And the pressures of evolution, whilst not being exactly the same, are going to operate in similar fashions to how they do here. So it wouldn't be unreasonable to think that a species that got advanced might be aggressive, similar to us. They also might evolve to the point of getting beyond that, like we're trying to. We just have to do it fast enough that we don't fucking kill ourselves. So there's that. So where do we get? No. Yeah, it'd be more like we're ants to them. We come in peace, shoot to kill. Yeah. You're wrong. All aliens speak English. Nope. Unless they might have learnt it from our radio, but why English? Why not any of the other languages? We're just English centric because that's what we speak. Oh, it's a cookbook. To Serve Mankind is a cookbook. That's cool. Vesta Freya. Okay. I don't know, has anyone else got any more questions for me? Because I've actually really enjoyed this one. I know I didn't invite anyone in like I normally do for these, but I kind of wanted to keep to the science more and see how I could cope with doing a longer one where it was just basically me driveling on. So I do want people to go over and see Scientist Mel's stream, which starts in about 25 minutes. She's going to be talking about sex and gender and the science of sex and chromosomes in sex. So what Jenny was talking about before with the SRY gene will come up, and also gender, both the social aspects of gender and the other science behind gender. So yeah, people should go and check that out because it should be really interesting. Knowing Mel, she will have done her research very well. And I don't want to keep going because I'm sure there's going to be a few people in the chat who actually want to go over and see what Mel's up to. So if you've got some more questions, throw them at me. Otherwise, I may just wind this up in a few minutes. But I want to say right now, I'm going to say thank you to you all for being here and asking such awesome questions. And really, to those of you that stumped me, well done and thank you. Thank you, Sammy, for multiple stumpings. You're a good stumper. I love the fact that you made me that you got me to answer the wrong question, which was brilliant, because I messed up Matroska brain and Boltzmann brain. So yeah, well, in my defense, they're both brains. So it's the casual spaceman. Hi, Matt. Why do I think Elon Musk has not used the single world hue? I've no idea. Who can say why Elon Musk does anything he does? I think it's mostly to support his own ego to a large extent. I mean, nothing against SpaceX. They've done a lot of really, really, really good things, but a lot of it's so that Elon can edify himself. But it's not necessarily a bad thing either. We need entrepreneurs who are prepared to put money where their mouth is, and he's got a big mouth, and that's a lot of money. So, and if it gets us to Mars, if it gets us out into space with better systems in the long run, I don't see a problem with that. But we really need to be pushing towards nuclear power in space, and then proper moon base and proper development of proper technologies for our space travel. But yeah, can I explain what happens in space-time on the other side of the event horizon of a black hole? No, I can't, because no one can, because we don't know. We have some ideas, but we don't know. That is the honest to goodness answer. I personally think that there will be something within quantum mechanics that preclude singularities. I don't think black holes are singularities. I think they are very, very, very dense quantum stars, where you're basically dealing with quark matter or quark stars, and that's the limit you get to. But you've just got to the point where there is enough gravity that light can no longer escape. So you have a black hole, but you don't have a singularity. I think you must come up against the Planck length at some point, and that would restrict how dense an object can get, which would effectively make it so that the concept of a singularity is a side effect of the maths that we use in general relativity, rather than actually being a physical thing in our universe. But that's only my own personal opinion on it. There have been many scientists who would tell me I'm insane and I'm wrong. So, yeah, but the truthful answer is we don't know. So you asked me another question. You corrected your question. Why do you think Elon Musk has not used the promised single world hole? Yeah, that's where I thought you were going in the current Starship design. It's probably an engineering issue. My guess would be it's harder to create the single world hole than it is multi-world. And I guess whilst they're testing the platform, it doesn't really matter. But there may also be a case that the multi-world doesn't have enough drawbacks to it to have to go for the higher engineering that would be required to have the single world. I don't know. We'd have to ask one of their engineers why they're doing what they're doing. My guess is it's probably got more to do with the testing of the system doesn't require them to do it, and it's easier to use a multi-world system. But yeah, I don't know. It reverses apparently, Jen. Yeah, there are lots of really good theories about what happens in space-time at the center of a black hole, and that's got to do with how the equations work out when you get things that are approaching singularity. But as I said, I'm not exactly sure that we'd actually have a singularity. I think that quantum mechanics is going to preclude that, which is my personal take. And I'm very uncomfortable with the concepts of point singularities. I think they are anomalies within our maths and not something that's actually physically able to happen in the universe, but that's just my personal opinion on that. But yeah, the concept that things apparently reverse and you can move along directional axes and actually move through time inside a black hole and vice versa, so you can things sort of mess around inside the black hole. It is a concept. Well, you say doesn't the arrow of time reverse? Time slows down as you approach the black hole from the point of view of people observing you from the outside. For you, it doesn't. It stays the same. The problem is once you're inside the black hole, if the singularity is true, then you have things where things moving on a certain pathway within the black hole will move along time curves instead of dimensional curves, which means effectively you could move backwards in time or forwards in time. But is time even relevant inside a black hole at that point? Time is relative, and in a sense, I think all those things would be irrelevant, well, especially to you, because effectively your existence ends in a black hole. So, yeah, we can't know. We honestly can't know. It's all just guessing from the way the equations solve, and I think that some of the solutions come out of a concept of mass that doesn't necessarily apply to the real world. So I'm of the opinion that black holes probably aren't singularities. So, yeah, we've got 15 minutes to Mel's stream. So, I'm going to wind this up. Again, I want to thank you all for your brilliant and absolutely amazing questions. Thank you, Matt, for joining in later. At some point, Matt, I really, really would love to have a discussion with you about this stuff, because you and I talking space would be freaking awesome. But, yeah, I really want to thank you all again. It's been brilliant. I plan on doing these more regularly. I want to do some of them with some guests on here, like Mero, Matt, Almost a Doctor. He has agreed to be on one of these when we will be talking about physics in more general terms, probably talking about quantum physics a bit. There's a few other people I want to have on a couple of these, so that you're not just stumping me, you're stumping other people as well. And I'm really kind of looking forward to that. So thank you all very much for joining me, for throwing up awesome questions, and I will see you all on the next one. Thank you, and bye.